Hey Serial Wombat fans, it's Jonathan Broadwell and I'm asking for your help. Now that the 2.1.1 firmware is out, I'm starting to look at what to put in 2.1.2 for the Serial Wombat 18AB chip. And one of the pin modes that I want to implement is an H-bridge. The question is, what is an H-bridge? Well, it's 4 transistors or some switches that allow a DC motor to spin in either direction. And so this is really good for like your tank steering robots or basically any motor that you want to run back and forth at different speeds. The Serial Wombat 18AB pin mode that I'm going to develop will use 2 enhanced digital performance pins. The pin mode I'm anticipating will take a 0 to 65,535 output. That's typical of a lot of the Serial Wombat pin modes, where 0 represents one extreme, 65,535 represents another extreme. So like for PWMs, it goes from 0% duty cycle to 100% duty cycle. Well, for an H-bridge, we're kind of turning that on its side and saying 0 is entirely one direction at full power, 65,535 is the other direction at full power, and therefore the middle, 32,768, would be off, no power in either direction. And so as we scale between those things, we will use a PWM to drive a variable amount of power in one direction or the other. Note that this pin mode that I'm working on is intended for DC motors. It's not intended for steppers, even though those also use H-bridges. Those will be in a later pin mode to be developed in the future. So there's a lot of different driver ICs out there for H-bridge driving, and essentially I went trolling through AliExpress and Amazon and different places looking to say, hey, what modules are already out there that people are going to want to be able to interface to? And the pin mode will call out each of these modules. A lot of these really work the same from an interface perspective. It's a matter of what technology they use and, their driver properties, cost, whether it's a BJT or a FET, things like that. But by picking a specific driver, you'll be able to know for sure that you've got good support. And if something new comes along, it's likely that the interfacing for one of these shown values will also work. If you're aware of a driver IC that's in common use that takes digital or PWM inputs, please let me know and I'll add it to this list. A couple of the features that I anticipate building into the PWM mode include configurable PWM frequency. That matters as you move from motor to motor. Small motors tend to need a slower PWM, larger motors faster. And a configurable off state. For some of these driver chips, you can turn off the motor either by putting both pins low or both pins high. And those have different effects from a physics standpoint, whether they are grounded on both sides or whether they recirculate current through the motor. And that kind of depends on whether the motor will sort of spin or sort of break as a result of being turned off. So that'll be configurable for motors where it's appropriate. It will also use the scaled output class. We've looked at scaled output in a few of the prior examples. These are the things that let you connect up one pin to drive another. So like for instance, in a prior video that you can see up above, we saw how to control servos and WS2812s and others from an RC in signal. In the future, you'll also be able to control an H-bridge based on an RC in signal, a pulse in signal, things like that. Also, it'll be possible to use an H-bridge based DC motor based on a PID input, which might be interesting with regard to being able to move in positive or negative directions in order to maintain a controlled interface. So that's kind of where I'm going right now. If you're watching this video, I'd really appreciate it if you'd comment, say, hey, I think you're on the right track. I think this is something I'd like to use. Or tell me, is there a driver IC I'm missing? Or is there some other feature? I don't do a lot of DC motor control. And so if there's some other interesting feature that you think, boy, this is a really, pretty critical thing to have in a DC motor driver, then please leave it in the comments below. Let me know. And expect to see this new feature in version 2.1.2 of the Serial Wombat 18AB firmware and the associated Arduino library, Python library, C# library. So that's all from now. Have fun. Keep making stuff. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.